everyone. That was, it sounds like we have somebody who doesn't quite believe in what we're selling today, so it's our job to convince you. My name's Jonathan. I'm a staff software engineer at Block working on GraphQL.
Hey, I'm Rudra. I am also a software engineer at Block working on the GraphQL platform team.
And today, we're here to talk about the journey that our team has been on over the last year to migrate from traditional subgraphs and to really truly adopt REST connectors, as well as the journey that we've taken with AI along the way. So just by a quick show of hands, who is using connectors in production today? All right. Who has REST APIs they would like to use connectors with? That's a lot more. That's an encouraging sign. You are in the right place. We can help. So today, we're going to talk about why we invested in connectors in the first place. And then we'll show very quickly how we began our journey and experimented with AI, and how we built on that using MCPs. And then we're going to take that raw manual input with AI, and we're going to make repeatable, structured workflows, and then show you how we're able to scale them out. And last, we're going to focus on not only how you build great GraphQL APIs using AI, but we're going to show you how you can build great customer experiences with generative UI. And then we'll close with questions. So again, if you have them, please save them, and we will invite you all up to the microphones at the end. All right, let's go ahead and dive in. To lay the groundwork for the connectors for the problems that connectors solve at Block, I want to give you a bird's eye view of our API ecosystem. We have over 700 teams building more than 3,000 different services, and they are all using gRPC and protobuf. The GraphQL platform at Block has grown over time, but bringing any one of those services to the graph has historically meant that the team has to learn a new way of working, and they also have to set up brand new infrastructure for a subgraph. That has a learning curve, an engineering cost, and an on-call support burden that many times these teams are unwilling to take on, and we have to convince them, or their customers have to convince them, that they need to do. And so we were actually in the audience at last year's Apollo conference when connectors were announced. And at the time, we were impressed, but we weren't sure that it was going to be a solution that would work for us, because as I said, all of our APIs are based on gRPC today. But then we got home, and somebody on the team realized, it wasn't me, but somebody smarter than me, that our frameworks actually provide a way to convert those protobufs into JSON already. And so we could actually use connectors. And so we started asking the most ambitious question that we could. What if we could use REST connectors to bring all of the APIs at Block to our graph? And I should have said this at the outset, but Block is the parent company of Square and Cash App. So there's a pretty broad domain across merchants and cash customers that we're trying to bring together. And so we started by building out a proof of concept. This was, can we get a single REST connector into our staging environment connecting to our network? And it turns out that we were able to do it, which gave us the confidence to kick off a hack week where we invited 8 to 12 other teams to come bring their APIs into the graph using connectors. It worked so well that within the span of 4 to 5 days, these teams were able to do their own subgraphs, as well as a couple others, that we decided to pivot the focus for our team for the coming months and quarters, and actually build the tooling to make connectors a default or core part of our GraphQL platform. And so we can't show all of those internal APIs today, so we're going to focus on an example of Square's developer API platform, which is similar in terms of complexity. There's a lot of different entities and relationships that we can highlight as we have connectors and AI build together. But we've only talked about one part of the equation so far, so let's shift our focus to AI. Over the last few years, the software industry and how we work in it has changed dramatically. LLMs aren't just chatbots anymore. They're full-on AI agents that can write code, run code, test it, and if it breaks, fix it. And if you're brave enough, it can even ship code to production. And at Block, when we ask, how do we apply AI to this task, we usually start by opening up Goose. Goose is an AI agent created by Block that's completely open source, that integrates with any popular model, whether that's ChatGPT or Claude. You can check it out on GitHub at the block/Goose repository. And it doesn't really matter whether you're an engineer or not. It works as a UI and as a CLI. So if you're interested in trying it out, Block's also running a hackathon that you can participate in. And I like Lego a lot, and I was very impressed when I saw the prizes available, but I'm not actually eligible. So please go win those great Lego sets. So we started using Goose for this just by asking, do you know anything about Apollo REST connectors? And Goose is a very confident bird, and it said, yeah, let me help you with that. But when we look at the code, we actually got back a TypeScript subgraph, unfortunately. It went out and actually found Apollo packages that connect REST APIs, but not quite the right ones. So we had to figure out, how do we help Goose and other AI agents level up? Because large language models are locked in time to the point that they're trained. And they're only trained on a particular, very public data set. And we at Block cared about being able to build products that can help our engineers with our data. And luckily, MCP was breaking out on the scene around the same time. We're not the only people with these challenges. I'm sure many of you have encountered those where you want to give proprietary information to the model to help your customers. An MCP is a specification very similar to how GraphQL is that provides guidance on how AI agents can do more. There's a lot of different parts to that specification, but the part that we care about most today are going to be tools. Tools are the part of MCP servers that can provide new knowledge and new capabilities to your AI agents, like how to work with REST connectors. And we've actually seen MCPs so far already. When we asked Goose to generate a REST connector subgraph for us, it was able to use the developer MCP that's baked into it to go out and modify those files and to run the commands necessary. But what we needed was an MCP that knew about REST connectors. And we were not as lucky as you, where GraphOS MCP had been announced. And so we went out and built our own. The config for it, actually this is the GraphOS MCP here, but the config is very similar. If you want to add an MCP to Goose or to your favorite AI agents, it's usually just a small bit of config to add the right URL into it. So if we enable these MCPs, and then we go back and run our own example, the first example, the difference between these is very dramatic. Instead of hallucinating and making up what it thinks we wanted, it's able to actually create a REST connector subgraph. The schema is idiomatic. The types are in the right place. It actually knows about the source and connect directive and populated them as it should have. And it's not a perfect schema, but it's so much closer that we were extremely confident in being able to scale this out to stakeholders for our platform. My favorite part, if you zoom in on the sidebar here, is it actually has a tests directory. We reran these examples prior to this talk, and Apollo, without telling us, had updated the GraphOS MCP to include the ability to test connectors. So we hadn't gone and found any docs or new capabilities for what the MCP should do, but we got this out of the box for free, being able to make sure that when a connector is generated, there's also a test that ensures that it connects to the right endpoints. So at this stage, we believe our AI agents are fully equipped and ready to get to work. So I'm going to hand it over to Rudra to talk about how we do that.
Thank you, Jonathan. All right. So AI has offered us incredible benefits, but of course, it's not without its pain points, right? Like hallucinations, variable outputs, fragile prompts. These are just a few things that developers struggle with when working with AI. Teams struggle to scale consistent behavior across workflows, agents, and without a little bit of structure, it feels a lot like just trial and error. This is where Goose recipes come into the picture. Goose recipes are well-defined, tested, and reusable prompt flows. And instead of reinventing prompt every time, you can just reuse these proven recipes for a little bit more consistency with your results. It's super easy to share Goose recipes. You can share them as a link or a file, and they can be run in the Goose UI or the CLI. They make your prompts a little less fragile because of their shareable nature and can give you a little bit more consistency, as we talked about earlier. Now, Let's look at the structure for a Goose recipe. Now let's reference back to Jonathan's example earlier to create an Apollo REST connector, right? We have a title, a description. We have some params. In this case, we have the API spec URL and the endpoint you want to convert to a REST connector subgraph. And you have the prompt, exactly the same prompt that Jonathan used earlier. We have extensions. In this case, we're using the GraphOS MCP extension that has information about the docs and the specs for the REST connectors and how they work. Let's go ahead and run that and see what we get. Cool. So after a few runs, we get something like that. But can we do a little bit better than this? What improvements or changes can we make here? So a few things you can notice on the screen. There's some hints on the screens to show you that too. There's no pagination, right? We're just returning a list of merchants. Do we want to add relay spec pagination or something like that? We're not correctly mapping from snake case to Pascal case that the type expects. Can we add some validation maybe to the workflow? Also, we are returning an ID type, like ID field. We're returning main location ID. Can we instead return the actual entity itself? So having a field for main location and then returning the location entity itself instead of returning that ID field. Now, of course, these are a few improvements you want to make to this workflow, right? But to create this production quality schema, we need to add all these additional steps, and this can make the workflow a lot larger and a lot more complicated. Instead of having all of this in a singular prompt, can we do it better than that? This is where Goose sub-recipes come in. They take a larger workflow and break it down into smaller pieces. It gives you a little bit more control and a higher success rate with larger and complicated workflows. Super simple to add. You just have to add a sub-recipe section to your Goose recipe, and each sub-recipe gets spun up with its own agent, own context window, and your own extensions. All right. So a popular model when building AI workflows and agents is the plan, execute, reflect model. The first phase is the planning phase, where you figure out what has to be done for the problem. The second phase is the execute phase, where you actually make those changes. And the last phase is reflect, where you look at the changes made, see if they suit your problem, if it's done a good job or not, validate, clean up, et cetera, right? Let's go ahead and apply that same model to our workflow in this case. We'll go ahead and create 4 different sub-recipes. We'll have one that just simply creates a connector from a template file, another one that writes those types and connector fields, et cetera, for an endpoint. And the next one will build those relationships. As we talked about earlier, we had the ID field, but we didn't have the entity, right? So building those relationships between entities for federation. And the last one is to actually clean up, validate, make sure those fields are mapped correctly from snake to Pascal case, as we saw earlier, and have a working schema. Awesome. And we also need to make sure that those sub-recipes are in the prompt, the prompt knows exactly how to call upon those sub-recipes and what to do with them. In our case, we are simply calling them sequentially, but you can also call sub-recipes in parallel. Let's see how we did now. Looks a lot better, right? We have relationships built out, so you can see that there's a location entity now, and there's a separate main location field that returns that location entity. Main location ID has been marked inaccessible. It uses a merchant connection object instead of just returning a list of merchants, so we have pagination. And also, it's correctly mapping those snake case fields to Pascal case now, the selection set for the connector. So now with these recipes and MCPs at our hand, we can truly scale up the order of magnitude of our AI workflows. We did this for a singular connector, but what if we have an entire REST API URL that Jonathan showed earlier with all those lines of code to create connectors for? Sounds extremely hard, right? Well, I'll pass it to Jonathan to show you how this can be done using a multi-agent approach.
Thank you, Rudra. I don't know about all of you, but I have a hard time remembering the same prompt if I want to run it over and over again, and so I love recipes for that use case. So far, we have covered a lot of territory, and we're kind of reaching one of my most favorite parts of this talk, where we get to dive into actual demos and see this working in practice. The promise of AI is that it helps us as engineers and engineering teams and organizations do more. And let's go ahead and dive in and take a look at what that looks like. If you want to run multi-agents or multiple agents simultaneously and apply them to the same problem, it's called multi-agent. And who knows if that will change with today's AI nomenclatures, but you can think of it like auto-scaling behind a load balancer, where as you have more work to do, you can start up new agents to handle those workloads. Which brings me to the favorite part of public speaking at conferences, is a live tech demo. So can we switch over to demo 1, please? If you can forgive one more Goose-related pun, all right, we're live. We built a demo application that we vibe coded called Flock. Let me just start that real quick, as well as starting up router with a quick rover dev command. OK, so you can see our starting place. And before I fully explain what Flock is doing, I'm just going to let it get started, because this is actually a hands-free demo for the most part. Flock is going to be working in the background, turning us into 10x engineers, while we just talk about what a multi-agent architecture looks like. We have given it just a slight bit of a head start. As you can see here, there is just a tremendous amount of endpoints that it needs to convert. We have a SQLite database backing this that we just said read. We had another agent read the OpenAPI spec and plumb it into the SQLite database. And then on the other setup side, we have a connector, just a very blank schema file that has a placeholder operation or query there that it can then populate the file to do for each endpoint, but it's not actually doing anything at the moment. OK, let's go ahead and switch back to Flock itself and then talk through what this setup is actually doing. We set up 4 different stages for an endpoint to work through. We do prepare, where this is all executing on my laptop. So it is actually setting up a Git work tree for each of these endpoints. Then we're having it process the endpoint, which is running recipes extremely similar to what Rudra demonstrated for us earlier. Then we have it review the code. So we want to make sure that as people-pleasing as AI can be, that it hasn't just gone off and tried to do something that was outside the bounds of what we expected it to do. And then merge, it's simply taking that Git work tree, merging it into the main branch, and then running a rover command to validate that the schema continues to compose as we expect it to do. Okay, so we've already made some progress here, and Flock is going to continue to work while we flip back over to the slides, please. All right. So if you've thought about multi-agents at all with your setup, and your first inclination was to say, let me just open up multiple terminals and try and run these commands simultaneously, I can tell you that that actually does work to a surprising degree. But simple parallel execution doesn't quite always work in a GraphQL context, because these ideas are connected. And something that an AI agent might generate in parallel may conflict with one another. So when you go to merge it, you may have an agent that has a difficult time resolving those conflicts. And the longer a process that you give an AI agent, it may do it right one time, but it may miss steps another time. So really breaking it down has helped us do more. And as you saw when I had Flock up on the screen, you can do some things in parallel, or you can't do everything in parallel, but you can do many things in parallel. So what we landed on is that we have 4 queues that allow us to optimize how the work gets sequenced. To avoid that conflict I described, for example, if you have a get merchant endpoint and a list merchants endpoint that you want to convert at the same time, we just have the agents pick those up in order when one of them is done. And that prevents, for example, having the same merchant type in different parts of the schema that it has to combine. Evolving our loops to be able to handle individual stages for individual endpoints helped us achieve a much higher pass rate for these workflows. And my favorite part, as I designed this and tried to figure out what's the best way for this to work, is that it's based on boring technology. The words I've shared about this should feel familiar, because it is simply queuing, polling, and workers. Flock is just trying to see, is there work that can be done in this queue right now? And if there is, it will start up a Goose session with a given recipe for a certain Git work tree. And then it just simply makes a request to Goose that says, can you write or review or merge this connector for me? And Goose, with its plucky positive attitude, will generally take up that task. But it has one other thing on top of it compared to the recipes that we saw earlier. Flock has a centralized orchestrator. In our case, it's a Next.js app, but it really can be anything. And then at the beginning of every single recipe, we give it the instruction to read the agent communication protocol. We tell it what type of agent it is, and then to get more information about the task at hand, in this case, converting an endpoint, and how to update the status of the queues so that the entire flock can fly in the same direction together. The protocol itself is extremely simple. We are just giving it two endpoints that are set up in our Next.js application, one to convert the endpoint itself, and the other, or to fetch information about the endpoint, and the other to update the status. And that is just saying, let's move from pending to processing, or ready to review to reviewing. OK, so let's go ahead and check in on how Flock has been doing. Can we switch back to demo 1, please? All right. OK, so we can see that it is still working. We have one item waiting to be merged, but I didn't quite talk long enough for it to get all the way to merge the list merchants endpoint that I was going to demo. It was queued already, so I'm actually going to pause I'm going to let Goose keep working. And I'm going to switch over here and change branches real quick. OK. And then I'll start Rover again. So Goose is an eager worker, but not always the fastest one. All right, so if I refresh Apollo Rover here, or router here, you can see that generally Goose will come up with endpoints that fit the schema that we were trying to provide. Here, I'm just using Apollo Sandbox to quickly fill out the different fields. And then if I run that operation, it's able to make the request successfully. I think during the prep for this, it took about 10 minutes, and we only had about 8 minutes. So if we let this run for a couple more minutes, it should actually get to the point where it's working. So we've seen Flock be able to handle all of these work to generate great APIs. I'm going to hand it back to Rudra to talk about how we build generative UI experiences on top of these.
Thank you. Can we go back to the slides, please? Awesome. All right. So we have seen how Goose recipes and sub-recipes can give you a little bit of structure when it comes to working with workflows. How they can create a lot of connectors, and of course, scaled up with Flock, we can create a whole bunch of connectors. But what further can we do with this, right? We have looked at how we can use AI to generate subgraphs. Can we also generate the experience that surrounds these subgraphs at the same time? Now, we will leverage AI to generate user interfaces from the same connector subgraphs that Flock just handed us. Block uses GraphQL to power a lot of its internal tool applications. What if we could just spin these up with just one command, or even embed them into the chat UI interface for your customer support or other use cases? All right, before jumping deep into a demo, let's talk a little bit about this workflow and how it's going to work. We will be using Jonathan's REST connector subgraphs created by Flock and start up the Apollo Server MCP with the Rover flag. So we have a locally running instance of the Apollo router. We will then take a use case from the user, and this use case will get split up into smaller use cases that get fed to different sub-recipes. These sub-recipes will generate an operation specific to that use case. So in this case, let's say we take merchants and customers from the user, and then that gets split up into two separate recipes, one for merchants, one for customers, and we'll get two resulting operations. One grabbing merchants, one grabbing customers. If they are related, if they have relationship between the two, maybe there's only one operation that gets generated. These sub-recipes are run in parallel, and they are validated using Apollo MCP. We will then generate the actual UI, following modern CSS and design best practices from these validated operations, and then we will deploy it, using your favorite deployment platform. In this case, we're just using Vercel. As the last step, as the bonus, we'll be embedding these UIs into the chat interface itself, and thinking about what that kind of use case brings us. All right, let's jump into the demo. Can I have demo 2, please? awesome. I'm just quickly starting Apollo router. Sorry, it's extremely small. All right. We have Apollo MCP and router running. All right. I have Goose UI loaded out here with my UI generating recipe, and I'm going to use that. Cool. So we can see all the 4 different MCPs we're using are loaded in. I'll have to, again, zoom in a little bit. All right. So let's think about a use case to use. Today, we'll be creating a dashboard that gives me my merchant details as a Square seller, along with my main location, and let me create and retrieve a vendor, maybe, for vendor management. All right. All right, it's loaded the recipe in, and we shall run that. All right, Goose, let's see you cook. All right, cool. So it's starting its workflows now. It's creating a to-do list. Now you can see it's going and introspecting the schema that we have available using Apollo MCP extensions. And while this workflow kind of happens, I'm going to go ahead and switch to the code to show you a little bit of that. All right, looks like this is legible. So some of this should look familiar. We have the supergraph YAML file. Again, got all our REST connectors. Not all, maybe a subset of what Flock generated. We have rudra.yaml. Again, it should look very familiar. It's using authorization header here and connectors preview. Config.yaml that actually gives us the MCP configuration. So we have operations to execute are in the operations folder, and we have introspection, execution, search, validate. All of those features are enabled. These are all the subgraphs we have. Again, thanks to Flock, it was easy to generate those. And looks like Goose has already done some amount of work for us. It's created a couple operations as we were speaking through the code. We've got merchant, we got vendor, we got get vendor. And let it continue that, but I'll show you what recipes we are using here. So I talked about generating an operation earlier, right? This is the recipe that we are using to generate the operation. So that use case gets split into smaller use cases. In this case, we are probably getting different operations for merchants, vendors, customers. Sorry, not customers, but merchants and vendors. And they are created using this sub-recipe. And our build UI YAML file is our actual main recipe. Now, it's quite complicated, but we have 6 different phases: analysis phase, we generate those operations using the sub-recipes. We have the UI dev phase, an integration phase that those validated operations are then fed into the UI, deployed to Vercel, and the embedding phase to embed it into the chat UI itself. And we have a few couple custom MCPs here. We are using MCP UI and Vercel, but we also use Apollo MCP and the built-in developer MCP. Cool. Let's go back and see how Goose is doing. Oh no, that does not seem great. Duplicate tool name. All right. Let's see if okay. That's not fun. Okay. Well. We can't see the full thing, but I have something as a backup, which I can show you all. All right, let's go back here. So, sorry, that's a failure of a demo. But it creates something like this, where you have running a dashboard. So it would create a merchant details section as we had requested. We have the main location. You have vendor management, and you have the ability to retrieve a vendor as well. Those are the things we asked for. And again, if Goose was compliant today, maybe this would have worked, but I'm just going to ask it to do this part. We're going to embed the UI in the, embed that UI into our chat. Let's see if that works, hopefully. Wow, it's not working at all.
Start a new chat?
Yeah, start a new chat. I think that's the best option here. All right. Start a new chat. All right, let's try that. Hopefully this new chat can do it. Wow, even the new one is not working. Summarizing it. Sorry, this is very unusual, but live demos sometimes just not very compliant with what you want to do. Right, let's try that again. All right, looks like none of that is working. And
if you disable the extensions besides MCP UI.
All right, let's try that as well. Let's disable Apollo MCP, and then try a new chat. Will that work? All right, OK. Thank you for the suggestion, Jonathan. All right, that's not very helpful either. I'll try a last time, and then otherwise I'm just going to give up.
I think we're just going to say that Apollo stole all of the agentic UI this morning.
All right, cool. I think I'm just going to give up here and just give an explanation of what we'll be able to see. You would be able to see that UI that we just saw in the browser embedded into the chat interface using MCP UI. So yeah, I'm just going to switch off the demo and move back to slides, I think. Sorry about that, everyone. All right, so yeah, imagining that demo went successfully, how would we do something like that, right? How would we embed something from the browser website into Goose itself? We use MCP UI. Now, MCP UI helps us build these interfaces directly into these agentic workflows, turning these tool outputs into actual user experiences. So raw MCP outputs are not very interesting. They're just data. So MCP UI helps you transform them into interactive visual interfaces so users can actually click, explore, act. In this case, I was going to show you how I can create vendors from Goose by having the UI be embedded there, but I'm sorry about that. Maybe if you want to catch me later, we can see that together. All right. Again, it's super easy to set up. In this case, the example we have here is a simple external URL being embedded into a chat interface. You have a survey SDK that generates these UI elements, and UI resource is the primary payload that you need to return to get your client to render this correctly. And on the client side, the main component is the UI resource renderer component. It inspects the resource's MIME type and either it renders HTML, external URLs, or remote DOM resources. Cool, and that kind of brings us full circle, right? We saw earlier with Flock that we can generate these subgraphs using AI. But it's not just letting us generate subgraphs. It's also letting us generate these experiences, these user interfaces around the subgraphs. All right, cool. Just to wrap up, we would like to summarize what we've kind of discussed, right? We talked about what the building blocks of these workflows are. We talked about MCPs, and we talked about recipes and sub-recipes that give you a little bit more structure when it comes to building workflows. We also talked about how building a workflow is actually a process, right? We started with a manual prompt, then we put that into a recipe and showed how that can be made repeatable. We then migrated it to a workflow by adding sub-recipes and fleshing that out a little bit more. And we ended by showing how this can be scaled up even more and even further by using a multi-agent approach with Flock. And I guess we have highlighted how far vibe coding has taken us. We have gone from 0 to 100. We have started with the REST API, and we created user interfaces from it. Again, you didn't really see that because of the demo failing, but sorry. But we are really excited to see how far vibe coding can take all of you. And we'd like to shout out the Agent Party Hackathon. You'll be building with GraphQL, Apollo MCP Server, and Goose to create these powerful experiences. And to cap it off, a year ago, we were all wondering if agents, models, protocols are even ever going to work. Today, we are heavily invested in building with them. And maybe a year from now, we'll wonder how we ever work without them. And with that, let's go to questions.
If you have any questions, please feel free to come up to the mics, and we can take a couple minutes to answer them today. Would you mind stepping up to the mic?
Hi, thanks for your presentation. And even though the demo didn't go well, it was really great. So I'm curious about how you come up with the recipes and sub-recipes. I'm particularly curious about the creation of the UI. And you had a file that kind of went in detail with the recipe, so we didn't really get a chance to capture it. But I'm just curious, what goes into the creation of one, and what's your starting point for that?
Yeah. I can speak for me first, and then feel free to tack on. Generally, when I'm working with Goose, and I know that I will eventually want it to be something I can replicate, my solution is not very advanced. I will open up a markdown file in Obsidian and start writing it out so that I can copy and paste it into the manual coding session, or the vibe coding session. And then eventually, that's what I will translate into a Goose recipe afterwards, so that once I have polished it and I know that it's working end to end, it's something that I can then save into the recipe format to use again within our team or to distribute to others on our platform to work with.
Yeah, and I think I mentioned the plan, execute, reflect model earlier a little bit. A key element when working with recipes is having those phases. Numbering them actually is very helpful. I think if you remember when I shared my screen for the recipe, I had 6 different phases for the building the UI, right? I had analysis, I had execution, and also had a cleanup phase at the end. And of course, keeping that model in mind, building the recipes with structured phases is quite helpful. And of course, starting off with a manual prompt, is the usual best bet. And then you can kind of evolve them over time into workflows and maybe go into multi-agent too. So yeah.
Yes.
Hi, thanks for taking my question. Demos are hard. It's all good. We've all been there. I have a question about security. So I'm imagining those REST APIs you were trying to move into GraphQL have authorization issues, like some of them are more authorized, less authorized. How did you deal with the authorization when mapping into GraphQL, and did AI help you with that?
Yes. So at Block, we have 2 different authorization models, one that is more tailored to our internal setup and one for our external one. Both of them tend to adopt the pattern that each field has its own permissioning. So if I add a business name field, then the endpoint that that's associated with might have a group-based access control that we can apply to that field. And we scale that out so that anytime a new REST connector adds that field to the graph, we apply that same permissioning process. And we utilize policy from Apollo Router that handles the pruning of those fields for us. So if we evaluate a credential and it doesn't have access to that field, it just is removed from the request.
Yeah, I have a question about Flock, which I thought seemed pretty cool. Was that just a demo for today's talk, or was it based on something you actually built for migrations internally? And is it a framework that's easy for someone to use yourself, or is it so easy to just build something like Flock from scratch with vibe coding that you don't need to?
It's a little bit of both. It was built out as a demo for this presentation, but it mirrors some of the principles and processes that we're utilizing internally. So for this talk, it's just working on my laptop with Git work trees. Internal to Block, we are experimenting with ways of running headless AI agents, so you would be able to distribute this to something running on a GitHub action, for example. So the principles are the same, and this setup, which you could run on your own machine with Goose recipes, can be translated into a more CI/CD workflow. Does that answer your question? Great. Go ahead.
Hi, I'm curious. So in the beginning, you mentioned that for what you were doing, you wanted to bring all REST APIs onto the graph. So I was curious if you could comment on the shape of the schema that you ended up with, and whether you had to tune your recipes to get something more desirable, maintainable. I'm curious also how you showed you ended up with multiple subgraphs. So how much of that came out of the box versus after tweaking?
Yeah, definitely after tweaking. It's a process that we have learned about and experimented with, and certainly our first attempts might have failed in different ways. And so for this example, we chose to break it down by different domains. So could we switch to demo 1 real quick? OK, so Flock has kept working throughout all of this, by the way. It's very diligent, but we organized it by these different domains so that things that relate to one another are they wind up in the same place. And that definitely helped us reduce the number of conflicts when it came time to merge those branches back into the trunk. So it meant that something like get bank accounts wouldn't have to have multiple types across different connector subgraphs. It could just see that it was already in the schema and either modify or extend it if it needed to, or use it if it didn't have to.
Thank you.
Yeah. Can go back to slides if we want. And yes, go ahead.
So I just had a question about, basically this is all kind of migrating net new REST APIs to your GraphQL subgraph, but we have a GraphQL service that predates connectors. And so we've already got the queries, mutations, entities defined in the subgraph. That's an ideal candidate to migrate to connectors. I'm wondering if you had any experience with anything that was already in your subgraph, or any subgraphs that were already existing that weren't just net new REST APIs to subgraph schemas.
Yeah, I'll take it.
Yeah, so we actually have a bunch of subgraphs that are already exist for us, and we want to move them to connectors because all these teams do not want to own these subgraphs. And we've had a good time, good experience at least, using connectors for that. We haven't done a lot of experimentation of moving, using Flock or using one of our sub-recipes or recipes to directly do all this work, but we ourselves have done that process of migrating from an existing dedicated subgraph to a connector, and it's been quite solid. I think 3 to 4 of our subgraphs have been like that. A biggest one being our permissioning one that handles all the permissions at Block. We moved that one over from being a dedicated subgraph to just a connector. And usually it comes down to business logic, right? Connectors are great for subgraphs that do not really have any business logic on top of their data. And we realized that a lot of subgraphs at Block are like that. They just have the data. All they're doing is taking the data from either gRPC or REST API and just returning that. And honestly, teams have ended up being the happier, right? Because they don't have to own a service. All they have to care about is that one schema file. So yeah, I don't know if that answers your question, but yeah.
Mechanically, the override directive that Apollo provides is a big part of that. And I believe they have a label as part of that directive that helps you shift traffic. So you can do that a little bit more safely and risk-free without having to just hot swap it all the way to the new subgraph and see if it works in prod. Thank you.